Okay, so I'm recording the solutions for test number 2 for fall 2020. So number 1, the answer was 0. Now, just so you know, the answer choices are shuffled for each student, so don't be alarmed if, like you said, A and you see D here. I have them shuffle it, and that's just really for more, I don't know, academic honesty reasons, if you want to say that. But really simple. All you have to do is just do the shortcut rule, so -8x -3 plus 2/4 x to the 1 power plus 0. Remember, 2 moves to the front. You drop the exponent by 1. -2 drops to the front. Drop the exponent by 1. Clean up a tad because you do have to substitute 2 in for x. And if you substitute 2 in for x, you get -8/8 plus 1/2 times 2. You get -1 plus 1. You get 0. That's all. So that should have been pretty easy. Number 2, this is quotient rule. The answer is this one right here. All you gotta do is just do the low d high, so x squared plus 1 times 1 minus the high d low, x plus 1 times 2x over low squared, and away you go. So I kind of suspect C is out. If I clean up the top, you should get x squared plus 1 minus 2x squared minus 2x. So you get -x squared minus 2x plus 1, D. So, okay, pretty easy, right? Number 3. Okay, this was a little cryptic, and there are a few questions. So just so you know, this looks just like, let me go to our lecture notes here. So this is why knowing your notes is a good thing. That looks just like the alternative definition of the derivative. So you have to be able to recognize that. And they'll do it often on the AP exam. Just so you know, actually, these questions are designed to be AP style. So in a way, you are getting your AP review along the way. So it's kind of a versatile kind of exam if you want to think of it that way, or serving multiple purposes. So you have to realize, okay, that's x20 minus 3x, that's e20 minus 3, x minus c, x approaching e. That looks awfully close. Actually, it looks just like this right here, f of x, f of a, x minus a, x approaching a. You can kind of think of all this right here as f of x, and all this as f of a, and e is a, and e is a. So now you know it's just a derivative, right? This is f prime of x, or sorry, f prime of a. Let me take that back. It's f prime of a, where a equals e, and your function is x20 minus 3x. So all you got to do now is just take the derivative, 20x19 minus 3, and then plug in e, and you're golden. You got your answer. There were some people who kind of botched this one. They thought like they actually had to find the limit, or they're doing some weird stuff. Again, just have to recognize that this is a derivative. That x20 minus 3x, just do your power rule and just plug in e. That's all you gotta do. And the AP loves doing, or the College Board loves doing this kind of stuff on the AP exam. So that's, and so yeah, so you haven't seen a problem quite like this for me. And I will do that with you guys from time to time. Excuse me. I will give you guys, I haven't quite seen, but you've seen the concept. You just have to make the connection. And that's the thing of a test as a learning instrument, right? This is a way for you guys to, learn. And if you miss some points, it's okay. And honestly, who cares what kind of, I mean, yes, don't finish with a C or D or F. I mean, try to, but, wherever your grade lands for the most part, as long as you're in the, A-B range, don't worry so much about that, because I think this is more of a learning instrument, right? This is what tests are for. And so if you miss this, then and now you'll be able to catch it next time. And doing well in the AP, depending on what colleges you go to, could help with college placement or with college credit, especially if you don't plan on doing STEM, you want to get out of a math requirement, that could help. I mean, we'll see what happens next year anyway with colleges, right? Things are still up in the air. Okay, this one here. This one is also a way of extending yourself. This is using the product rule. So you're told that K is a product of F and G. You're asked to find K prime of 3. So what you need to do is do the product rule. And that's K prime of X. Of course, we're plugging in 3, right? So actually, I don't know why I wrote the X. That was kind of dumb. So F prime of 3 is 5. G of 3 is 2. F of 3 is -1. G prime of 3 is -2. And you should get 12. So that's a fill in the blank. So that's number 4. Number 5. So actually, do expect me to ask whole concepts. This is an IVT for continuous functions. Hopefully that was kind of a clue and that these are just y values and there was no derivatives involved. So I will kind of make this test somewhat cumulative or spiral old stuff, you know. So the best way to handle this one is just plot the points. So 0, 3. So 1, 2, 3, 4, 5. So 0, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So that's going to be 5, 6, 7, 8, 9, 10, 10, 15. Okay, 4, 4.5. 6, 3. 8, 2.5. 13, 4.4. And it's continuous, so it's not going to have any breaks in it. Okay, I missed. Let's try that again. And you want y equals 4. So it hits it 3 times. That's all. That's all you got to do. So, and that's just using the IVT. Because IVT states that any y will be taken on if you're continuous in an interval. So like we're continuous in this interval, and y does equal 4 between these two numbers. Likewise between these two numbers, and likewise between those two numbers. So that's why it's 3 times. Okay, number 6. We did do this. That was number 39 to 3.2. I don't know why I still remember that. I think some of you guys asked about it. But anyway, hopefully got this one right. You just set them equal to each other and plug in 1 for x. That's going to ensure the continuity part, that the left-hand limit equals the right-hand limit. So 1 plus b equals a. Also, it's differentiable, so you could say take the derivative of each side with respect to x. So 1 plus 0 equals 2ax. Remember, derivative b is a constant. So b is a constant derivative, that's going to be 0. Plug in 1 for x. A is half. If a is half, b is going to be -half. And there you go. That's number 6. Number 7. So here you actually had to show some work. And you guys did great with this. So is it continuous? So you have to go through all the rules of continuity. Does f of -1 exist? Does the limit as x approach -1 exist? And of course, is f of -1 equal to limit as x approaches -1 of f of x? So yeah, of course it exists. It's right there, right? So f of -1 is going to be -1, -1 squared plus 3, just 2 straight up. The limit as x approaches -1 of f of x, that's going to be easy. Excuse me. That's just going to be, if you look at left, right-hand limits, that's going to be 3 times -1 plus 5 equals -1 squared plus 3. 2 equals 2. Boom, there you go. And of course, they equal each other, right? So that's why, f of -1 equals the limit as x approaches -1. For differentiability, I see you can use a shortcut rule. So 3 equals negative 2x. So you would get this on this side and this on that side. Of course, those don't equal each other, so you say no, not differentiable, because the left-hand derivative did not equal the right-hand derivative. And I said use the shortcut rules because I don't want you taking too long to do the limit definition. I already saw that you guys did the limit definition of the quiz that we had, so I didn't bother to ask that on this test. Number 8. So again, this is a way of extending yourself a little bit. That is going to be a slope of 2, right? You guys should know slope. You guys have done that a million times now, so it should not be a problem. 6 over 3 equals 2. And we parallel to that. So it means that g prime of x, or g prime negative 1, I guess in this case, has to equal 2. Because you're told that the line tangent the graph of g at x equals negative 1. Remember, that's going to be g prime of x. We got to plug negative 1, and that's going to be parallel to that, so they have the same slope. So if you have some funky curve and negative 1, well, actually, it's kind of weird the way this is drawn, but let's say something like that. So that slope has to be 2. So you got to make those connections, the algebraic graphical connections. That's what's happening here. Well, the derivative is easy. That's just 2x plus b. And you got to plug in negative 1 for x. You just solve for b. So b equals 4. And trust me, when we get to more advanced stuff, when we start doing AP review in the spring, this stuff you'll be able to go through it quickly. You know, it's just going to be second nature. Oh, Teddy, you're here. Let me mark you as present. So today we're just going over the test. I'll just say I didn't see you. There we go. Okay. And actually, I kind of recorded it. That's okay. Who cares? Let's move on. Number 9. Number 9, you have to use a calculator. So I wanted you to kind of you do a little bit of calculator work. So obviously, you have to like see where this crosses the x-axis. So you got to like, you know, graph, you know, this thing, which I think kind of looked like that, I think. And I think it crossed at 0.606. And the way you do it, you just simply go to Y1, type in all that junk, and then hit graph, of course. But then you're going to want to hit second trace and pick 0. Or you can go to Desmos and locate it too. That would be just fine. But then you got to go back to the calculator and do n-deriv. And you got to type in what you have stored in Y1 and do x equals 0.606. And you should have got like 2.96, I believe. If you're a little bit off, like maybe you rounded this a little too soon or whatever, or you made, I don't know. Don't worry, or if you didn't pay attention to the directions, you didn't round 2 decimal places, that's fine. I still give you full credit. So don't worry about it. So that's that one. And last number 10, that was the fun one. That's where you had to generate a graph from this information and then state the reasons why you're not differentiable. So for these here, what I did was I said, okay, well, f has to exact 2 zeros, so I have 2 x-intercepts. And not differentiable at these places, so I'll do my tick marks. And just do right here. F2 equals negative 4. That's easy peasy. So done. You're told that you're not. So this is kind of interesting. This right here, you have positive and negative infinity as these limits of the derivatives. So that's going to be a cusp. And you're also told that f of negative 5 is 2. And that the limit as x approaches negative 5 is that. So this means that we're definitely continuous at that point at x equals negative 5. But it is a cusp. And you're also told when you go further to the left, that's a horizontal asymptote. That's your end behavior on the left side is negative 1. So I'm probably going to do a horizontal asymptote and draw something kind of like this. Now I am crossing the x-axis twice, mind you. There are a few ways you could do this, but I felt like kind of doing this. And I don't know what to do after this. But let's see what happens at 2. So obviously these are not the same. these limits here. So that it's not continuous. That's a jump discontinuity when that happens. We talked about this. So again, old stuff. And we do know that at 2, it's going to be -4. So I'll probably do something kind of like this, maybe. You could do that. I mean, that's totally fine. And I'm guaranteed I'm not differentiable at these 2 places. And what's going on at 4? At 4, you're told that the derivative is 1 from 2 to 4. So it means I do need to do a slope of 1, like that. And then -2, so I gotta make it kind of steep, like that. So that guarantees that you have a corner there. Do I have exact 2 x-intercepts? I do. I have covered all x values for my domain. Definitely not differentiable at those places, and definitely taking care of that. So that's how you can do that graph. It is somewhat open-ended. If you so desired, I mean, you could have got a tad creative, I suppose. I'm just trying to think. I don't know. I mean, I guess you could have done this. It may just do something really kind of weird like that. That would have been fine if you had that. So, but you are told that you have a point at 2, -4, and a slope of 1. So you couldn't really go pretty much past that, right? I mean, you pretty much are stuck with that. And then you have the slope of -2 at when x greater than 4. So yeah, so that's the test in a nutshell. And so again, -5 was a cusp, at 2 was a jump discontinuity, 4 was the corner. So for the most part, I feel like you guys have mastered this stuff, and I think and I didn't do it as a cookie cutter. I mean, I wasn't like, oh, here's a bunch of derivatives, find it, blah blah blah. No, like I actually forced you guys to think deeply about this. So you guys are totally getting this stuff. Very happy about this stuff. Okay, so let me stop the recording.